We got a little bit left in 14.4 to go over today, and a little bit more of the inverse stuff tomorrow. That'll get us into 14.5 for Wednesday and bits of Thursday probably. We have a little bit of a half day Friday, the full day Monday, and we will test out of chapter 14 come next Tuesday. There's a lot of info as far as the test and everything like that. We'll worry about that as it gets a little bit closer. Next Wednesday, obviously it's another half day. Works out perfectly fine because section 10.1 only takes about 6 minutes, and you guys will be fine. We've all graphed parabolas, so we'll be that back. Yes, sir. No, that's the week, the following week. Because this is the conferences here, and then we have the 4-day week. Come back for one day, the Tuesday, then Wednesday, Thursday. Wednesday we don't have school because of the ACT. Thursday we have a half day, so it's like. I don't know why they don't take the ACT on the days of parent-teacher conferences when we already have half days, so it makes no sense. So,
wait, what days?
The following Tuesday. All right, so let's look at the first grouping of problems from last week. In the general solution stuff, that first 4, what do you want to look at? Yes, ma'am.
25.
All right. Number 25. When we're working with these problems, we have to solve for x, and we have to use a bunch of different tools to get there. If I'm looking at this, both of these two terms, sine of x times cosine of x minus 2 times the cosine of x, both of those guys have what in common besides x? Both have cosine, don't they? Two things have the same thing in common, and I have got one side equal to 0. That means I'm going to factor it out. Now I have two terms set equal to 0. I set both of them equal to 0. Cosine of x is 0. Sine of x is 2. What I did there is I moved the 2 right off the bat. I'm going to shortcut a couple of these. Hopefully it won't be so bad. Which means I have to take the inverses now. Where is cosine equal to 0? Start thinking about ordered pairs. If I'm at 0, that's 1, 0, isn't it? It's not 0. It's at pi over 2. Where else is it at? 3 pi over 2. So my solution here would be at pi over 2 and 3 pi over 2, but it's asking for the general solution. So now, if I start at pi over 2, if I just add pi, aren't I here? If I add pi, aren't I back here? And so on and so forth. So I can just write pi over 2 plus pi n for this case. Yes, sir?
So why did you skip the like pi and 2 pi? Like why did you just go straight to 3 pi over 2?
Where's cosine 0?
At pi over. Oh, okay, I see.
Okay. Now, sine, yes, sir?
Are we not allowed to add stuff over? Because it doesn't kind of, yeah. So because if you added the 2 cosine to the other side and then divided by the cosine of x,
You get something equal to 1. You're trying to find zeros here. You want to get that side equal to 0. Okay, that's kind of the trick.
Yeah.
Now, sine equal to 2. Is anything going to give you something equal to 2? No. There's no solution on that one. So your answer would be pi over 2 plus pi. Okay. What else in that first grouping? I know there's been a bunch of them throughout the day today. 26 is the same basic principle. Factor out a cosine. We had to do what, 27? Did I walk you guys through 27, the scenario on that one?
Where you
The U substitution. Did you guys get that okay?
Yeah.
No. U substitution is a big trick later on. It's a huge thing that you use in pre-calc and calc all the time. We get 2 sine x, sine squared x, minus sine of x minus 1 is 0. Right now I have to figure out what times what's negative 2, I add together to get negative 1. But I have all those signs in the middle. By using what's called U substitution, I'm letting something ugly look like something pretty. By saying let U equal sine of x. It just shortcuts, it doesn't shortcut the work, it shortens the nastiest of all the different letters you're writing out there. You're able to still simplify and factor the same way, but without all that sine mumbo jumbo messing it all up. So when I do that, what times what is negative 2? I add together, get negative 1.
Negative 2 positive 1.
Negative 2 positive 1. So you wind up with 2u squared minus 2u plus 1 minus 1u, excuse me. I'm setting this up to be a factor by grouping problem again. When you do your factoring by grouping, you're taking GCFs out, 2u, take out a 1. Now I have 2u plus 1 and u minus 1 as my two separate terms. But what did I say that u was equal to?
Sine of x.
Sine of x. So I just substitute back in sine of x, and it just makes it a little bit easier to work with. So I have 2 sine of x plus 1 is 0, and sine of x minus 1 is 0. So where do I get a sine value equal to negative half? And where do I have a sine value equal to 1? So what triangle are you in if you're doing sine at 1/2?
It's pi over 6.
30/60. It's pi over 6, very good. Now I'm negative, so what quadrant am I going to be in for the negative? My reference angle is a pi over 6. Sine is positive in 1 and 2. Negative in 3, 4. So in the third quadrant, what is that value? 7 pi over 6. And then in the fourth quadrant, it is?
11 pi over 6.
Now, in this case here, is there a constant value of n that I'm adding with pi to get from 7 pi to 11 pi and then back to 7 pi each time? It doesn't work. There's no constant value to go from here to here and then back to here to here. So in these cases, you just tack on the 2 pi in for both of them. Okay? That's how you have to go back over and around. And then lastly, where is sine equal to 1? Remember,
Wait, 2 and
pi over 2. Remember ordered pairs. 0, 1. It's at pi over 2. Is it anywhere else equal to 1? Nope. So what do I have to tack onto that to make it a general solution? Plus 2 pi n.
Why are you putting on 2 pi?
It's a general solution. Those first 4 problems are general solutions. So you're just trying to figure out how much does it take me to get back to that same spot.
Okay.
So we have general solution.
That's only for general solution.
Only general solutions. You have to figure out how often you're repeating that value. Okay. What else? All right, let's go look at the other ones then. With you're working on the other side, the solve them. It just means within one revolution. List all the possible solutions within one revolution. Within one time around the circle. That's all it can be. Well, yeah, because that's general. The general ones were the ones that were just saying, hey, how often do you get to that? That's when we tack on that 2 pi n or a pi or something like that. Here, you're just saying, what are all the possible answers? Yes, ma'am.
Are we gonna have to do them when they're not in between, like the first?
What do you mean? Like within
Like if they're not
4
in between,
revolutions?
yeah,
or-
when they're not in between 0 and 2 pi, when they're like between 4 and 6 pi.
That's a good question. I never thought of doing it like that to you guys. No, I'll keep it standardized. That is a good, that is, you know what, that is something I could push you guys to do between 6 and 8 revolutions, and you just have to figure out how do you add in your pi values. That's a really good question. Maybe. Everybody boo Morgan now.
Sorry.
I seriously thought you were going to throw it.
No, I already thought she was.
Take a look at 40. I want to talk about 40. In these problems here, we've been trying to get one side equal to 0. That way we can do factoring, we can do some stuff like that. What is sine times secant? sine over cosine, isn't it? So it's tangent. Now, if I have tangent squared of x equals tangent of x, I need to set aside equal to 0 in order to make these work, because we're trying to find our zeros. How do I move a tangent x? Subtract. I think I might have accidentally said divide earlier, and that created a 1, but if you create 1, you're not actually finding all possible answers. It's all my fault, yes, I know. But once again, I got big shoulders, I can deal with it. What do they have in common? Tangent. So where is tangent equal to 0? And where is tangent equal to 1? What's that? Yeah. When it's equal to 1, it was where? At pi over 4? Now, if it's at pi over 4, where else is tangent positive? So what's the third quadrant solution for that? Now think about this. Where is tangent going to be equal to 0? Tangent's what over what?
Sine over cosine.
It's going to be sine over cosine. In order for tangent to be equal to 0, which one of those has to be
The
0?
x-axis, or
It's got to be on the x-axis, doesn't it? Because it would be 0 over 1, or sine over cosine. So it would be at 0, or 0 over negative 1. So you have 4 possible solutions. 0, pi, pi over 4, and pi over 4. Okay. How'd you do on the one that you had to use your calculator? Did you know which one you had to do that on? The one where you had tangent was equal to a half? Yeah. If you used your calculator on that one, you should have done all right. If you were in radian mode, was it like 0.46, I believe?
Yes.
Okay. Let's see on what number is that, 36? Okay. On 36, you guys should have had tangent of x equal to a half. When you do that in your calculator, make sure you're in radian mode. The reason we're in radians again is why? Because I said so. More specifically, your interval is in radians. If your interval is in degrees, then you can be in degree mode. In this case, it's in radians. So it's in radians. When you guys did that, what was it? X was 0.46, I think. Is that right? Richie, is that what you got? Yeah, and then you did the inverse tangent. You get 0.46. So this is some crummy decimal of some crummy fraction that put you into what quadrant because it's positive? It's in the first quadrant, right? So I don't care where it is. All I know is that this is 0.46. What other quadrant was tangent positive? Third. So how do I get this angle?
add it to
Add it to what? Pi.
a pi.
So my two separate answers in this case would be 0.46 and 0.46 plus pi. You can just leave it like that. You don't have to give me decimals on the pi value.
Okay, let's say it's in the fourth quadrant.
If it was in the fourth quadrant, what I would... Go ahead.
I mean, I don't know what pi to add or subtract.
Okay. Think about reference angles. If you have a reference angle, we'll use pi over 6. If this is your reference angle up here, in the second quadrant, you have to come up, right? Pi over 6. So pi minus pi over 6 is 5 pi over 6. I'm in the third quadrant, I have to add pi to it. So I get 7 pi over 6. In the fourth quadrant, I have to come down off of 2 pi, so I subtract pi over 6 and I get 11 pi over 6. So if I'm going to be in the fourth quadrant here, I would take 2 pi and subtract 0.46, whatever it may be. Okay. Same rules for reference angles as they were before. That doesn't change. You guys were good at that, though. Oh. Any others of the And that second half that you want to look at, I know most of you guys are in here in flex and going over some of it anyway. So. All right, let's look at some of the funkier ones where things get weird. Hold on to this one because I did basically all of them. I want to look at number 12. Let's see what happens when it starts to get real. As it gets more and more interesting. Oh, that's fine. I don't care. No, that's fine. That's not a big deal. Is somebody? If you can balance it on your eye, then you.
I asked him to like walk around the studio.
Yes, sir.
Yes, we do that. No, I know. It's okay, Richie.
I have these on a sheet here for you too. But let's look at number 12 here to start with. It's on the A side. Just send them all over that way. Stand. 5 feet. Let me show you guys kind of a weird scenario that happens. If you look at this one, we have two signs. Yes, sir.
Why is there no left on these macro sheets?
Because they're just problems. That's all they are. You're supposed to do a bunch of other sheets. That's why.
Nobody's,
I know.
nobody's, like, doesn't have enough utilization to set out a separate piece of paper and do these math problems on a separate piece of paper.
Well, that's why I said just a separate sheet of paper.
We need another, we need more room here, so we can just do it right now.
Notice I have a sine, 2 sine squared, and I have a cosine on the other side. When you're trying to solve trigonometric equations that involve 2 different trig functions, what you want to do is identify which trig function is the smaller power. In this problem, which one is the smaller power? The cosine. That tells me I want to rewrite sine squared in terms of cosines. How can I rewrite sine squared in terms of a cosine? Very good. Other way around. 1 minus cosine. What I'm doing here is I'm going to rewrite sine squared as 2 times the quantity 1 minus cosine squared equals 2 plus cosine. By doing that, I now have everything in terms of the same trig function, which is going to allow me to factor and solve easier. Now, distribute. 2 minus 2 cosine squared of x is 2 plus cosine of x. Yes, sir?
How did you change sine squared to 1 minus cosine squared?
Sine squared plus cosine squared is?
Oh.
It's magic. So now, this turns, we want to get one side equal to 0. Every single time we had to get something equal to 0, one side equal to 0, no matter what we were working with, factoring or solving equations, we always wanted the highest degree of our problem to be positive. Right now, it's negative. Does everybody see that? It's negative cosine, or negative 2 cosine squared. So that means I'm going to take everything on the left-hand side of this equation and move it to the right. I'm going to set the left side equal to 0. So I'm going to subtract 2. I'm going to add 2 cosine squared x. When I do that to the right side, I get 0 equals 2 cosine squared of x plus cosine of x. Because when I subtract 2 out, it's gone. Everybody agree? Now I'm back at what do those 2 terms on the right have in common? Cosine. Factor it out. Yep, just factor out the cosine squared now. Not cosine squared, excuse me, just cosine. So I get cosine of x times 2 cosine of x plus 1 all equals 0. Do you guys all agree that I have to set both those two terms now equal to 0? So I'll have cosine of x is 0, and cosine of x is negative 1/2. I've been shortcutting that second step all day today. Is everybody okay with that? Knowing that 2 cosine x plus 1 has to equal 0, I know I'm going to subtract 1 divided by 2, just move it over. Where you are with that? We just did this problem. Where's cosine of x? Where does it equal to 0? Pi over 2? 3 pi over 2. Okay. Where is cosine equal to negative 1/2? Which triangle are you in? We're in the 30, 60. Which one of those gives me the negative 1/2 of the cosine? The pi over 3, very good. So if I reference angle is pi over 3, and I want cosine to be negative, what quadrants will I be in for the negative cosine? 2 and 3. So I'm here and here. Second quadrant, cosine of what is negative 1/2 then? If the reference angle is pi over 3. Bounce it up. 2 pi over 3. Bounce it down. 4 pi over 3. And there's my 4 solutions. Again, it works out to be the same, basic same stuff we were working on yesterday, but the only trick entailed within this is sometimes you might have to rewrite in terms of something else. Yes, ma'am? Yeah, 60 degrees. It's 60 degrees of pi over 3.
Oh, God.
That's okay.
Well, you only wrote up to 30.
Oh, sorry. Yeah, sorry. I was running out of ink.
Wait, so those are all solutions? So we
Yeah.
have 5 different, all,
Come on. You guys, it's like April. You guys don't realize I'm not funny?
so wait, so pi over 3 doesn't count as a solution?
No, that's just the reference angle. We use that, the reference angle, to figure out where it's going to be. Pi over 3 is not a solution. It's just the reference angle for this. Just like every time I start the reference angle, then I start to figure out where do I have to go with that.
Okay.
Sometimes the reference angle is a solution, but sometimes it's not. In this case, since cosine, I'm looking for the negative half.
Since it's negative half, so you went into where cosine's negative. Okay, yes.
Okay.
Okay, I got it.
There's another one on here I want to look at. Let me give you a hint. In this case here, it's number 13, I have 2 secant squared x plus tangent squared x minus 3. Both of those guys have the exact same degree, don't they? I'll show that up first before I get to the hint. Hold on a second, hold on. If I want to rewrite one of these trig functions as something else, which one would be easier to rewrite as? Secant into tangent, or excuse me, secant squared into a tangent squared, or tangent squared into a secant squared? Secant squared into a tangent squared. Yes. So secant squared is equal to what in terms of tangent? So it would be 2. Everybody agree with that? What do you think you'd have to do next? No, we're not doing factorial. It's true. This is all equals 0. Are we okay with that so far? It's Paul. Yes. Okay. What's 2 tangent squared plus tangent squared? 3 tangent squared. What's 2 minus 3? Could you finish that? Okay. I'll give you one other hint. Because I'm going to have you guys do numbers 9 through 18 on this sheet. On the A side. Take a look at 9. What's that? I know. I said, yeah. I said, could you finish it from here? Yeah, you can. I got faith in you. What are you going to do first? Oh, I'll let you write it first. Sorry. Correct. So what do you want to do first, Richie?
Add 4.
Add 4. Can I go ahead and say that secant squared of x is going to equal 4 over 3? Is everybody okay with that? Okay. I hope so. Now, secant squared is the inverse of what? Cosine. Oh. So if I take the inverse on the left-hand side of this equation, what would I have to do on the right-hand side?
Inverse.
What's the inverse of secant squared? Cosine squared. What's the inverse of 4/3?
3/4.
You can finish it. So on this sheet here, the A side, do 9 through 18. Okay? We'll continue with this stuff tomorrow. You'll need a separate sheet of paper on this. You will not have any room. And plus, we're going to do stuff off the back of it tomorrow. There's a lot of inverse stuff on the back. Okay? If you lose it, I did throw a copy of it up on the website, so it is all there for you. So if you want to go through that. Yes, ma'am? You stop this.